Welcome back. Did you know there's a metal that's more valuable than gold yet remains in the shadows? Prepare to be amazed as we unravel the mysteries of palladium, a captivating element that holds the key to countless innovations in technology and industry. With its shimmering shine and incredible properties, palladium not only surpasses gold in value but is also essential in powering our modern world. From the catalytic converters in our cars to high-end jewelry that dazzles the eye. Join us on this thrilling journey as we explore why palladium deserves the spotlight and how it influences our lives in ways you've never imagined. Stay tuned. The adventure to uncover this extraordinary metal starts now. Discovery. The year is 1802. The world is still adjusting to the discovery of uranium and titanium when British chemist William Hyde Wollaston isolates a new metal from a crude platinum ore. He names it Palladium after the asteroid Pallas, itself named for the Greek goddess of wisdom. But Wollaston's discovery is met with skepticism. Fellow scientist Richard Chenevix even declares it a fraud, merely a platinum alloy masquerading as something new. Wollaston, determined to prove his finding, offers a substantial reward to anyone who can demonstrate palladium is not a new element. The reward goes unclaimed. What Wollaston couldn't have known was how this metal, dismissed by some of his contemporaries, would one day become one of the most valuable substances on Earth, trading at prices that would occasionally surpass even gold. Properties. Palladium belongs to the platinum group metals, 6 elements with similar properties that often occur together in nature. But palladium stands apart with its unique characteristics. It's the least dense and has the lowest melting point of the platinum metals. A cubic meter of palladium weighs approximately 12,000 kilograms, nearly 1.5 times heavier than lead, yet lighter than gold or platinum. But what truly distinguishes palladium is its remarkable ability to absorb hydrogen, like a sponge soaking up water. At room temperature, palladium can absorb up to 900 times its own volume in hydrogen, altering its crystal lattice structure without breaking apart. This property makes palladium a crucial element in hydrogen purification and storage technologies. Perhaps most valuable is palladium's exceptional catalytic ability, its power to facilitate chemical reactions without being consumed itself. This seemingly magical property becomes the foundation of palladium's most important applications in our modern world. Catalytic converters. The 1970s marked a turning point in our relationship with the environment. The Clean Air Act in the United States demanded dramatic reductions in vehicle emissions. Engineers faced a daunting challenge: how to transform toxic exhaust gases into harmless substances before they entered our atmosphere. The answer came in the form of the catalytic converter, and at its heart, palladium. Inside every catalytic converter is a honeycomb structure coated with precious metals, primarily palladium. As exhaust gases pass through this structure, palladium catalyzes reactions that convert carbon monoxide into carbon dioxide, hydrocarbons into carbon dioxide and water, and nitrogen oxides into nitrogen and oxygen. A single gram of palladium can purify the emissions from a vehicle driven for thousands of miles. Today, catalytic converters remain the single largest application for palladium, consuming over 80% of annual production. But this dependency comes at a cost. Global automotive manufacturers require about 10 million ounces of palladium each year. With limited supplies and concentrated production, the automotive industry exists in a delicate balance with palladium availability. Beyond automobiles, while catalytic converters dominate palladium demand, the metal's reach extends much further into our daily lives. Look at your smartphone. Within its circuitry, palladium plays a crucial role in multi-layer ceramic capacitors, the tiny components that store and regulate electrical energy. A single smartphone may contain dozens of these components, each using a small amount of palladium. In the medical field, palladium-103 isotopes are used in brachytherapy to treat prostate and other cancers. The radioactive seeds, about the size of a grain of rice, are implanted directly into cancerous tissue, delivering targeted radiation with minimal damage to surrounding healthy cells. Dentistry has long relied on palladium alloys for crowns, bridges, and partial dentures. These alloys offer excellent corrosion resistance and biocompatibility, though their use has declined as ceramic alternatives have improved. In the chemistry lab, palladium catalysts have revolutionized synthetic organic chemistry. The 2010 Nobel Prize in Chemistry was awarded to Richard Heck, Eiichi Negashi, and Akira Suzuki for developing palladium-catalyzed cross-coupling reactions, methods that allow scientists to build complex molecules with unprecedented precision and efficiency. These reactions have transformed how we synthesize pharmaceuticals, agricultural chemicals, and advanced materials, mining and supply. Despite its value, palladium is rarely found in concentrated deposits. Instead, it typically occurs alongside other platinum group metals, as well as nickel and copper. The world's primary palladium sources are concentrated in just 2 countries, Russia and South Africa. Together, they control over 75% of global production. Russia's Norilsk nickel operates in the Arctic wilderness of Siberia, while South Africa's mines plunge deep into the Bushveld igneous complex, a geological formation over 2 billion years old. North America contributes modest amounts from mines in Montana and Ontario, while smaller quantities come from Zimbabwe and a handful of other countries. This geographic concentration creates vulnerability. Political tensions, labor disputes, or infrastructure failures in either Russia or South Africa can send palladium prices soaring. In early 2022, prices reached an all-time high of over $3,000 per ounce amid supply concerns. Secondary recovery, recycling from used catalytic converters and electronic waste, has become increasingly important, now supplying about 25% of annual palladium demand. But recovery remains challenging and energy-intensive. Future challenges and opportunities. As we look to the future, palladium stands at a crossroads. The transition to electric vehicles threatens to diminish its primary market, as battery electric vehicles require no catalytic converters. Yet hybrid vehicles often use even more palladium than conventional cars, potentially extending demand through the transition period. Meanwhile, new applications continue to emerge. Hydrogen fuel cells use palladium membranes for hydrogen purification. Advanced semiconductors incorporate palladium in their manufacturing process. And researchers explore palladium's potential in carbon capture technologies and artificial photosynthesis. Perhaps most intriguing is palladium's role in groundbreaking materials science. Palladium-based metallic glasses, metals with amorphous, non-crystalline structures, exhibit extraordinary strength and elasticity. These materials could revolutionize everything from surgical instruments to aerospace components. From its contentious discovery to its pivotal role in modern technology, palladium has traveled a remarkable path. Once obscure, now indispensable, it remains largely unseen by those who depend on it daily. As we face unprecedented environmental and technological challenges, this precious catalyst may yet reveal new properties and applications. Element 46, the metal named for wisdom, continues to teach us about the extraordinary potential hidden within the elements of our world. In our quest for sustainable technologies and cleaner environments, palladium stands as both challenge and opportunity. A metal of contradictions, rare yet essential, expensive yet irreplaceable, ancient yet thoroughly modern. This is palladium, the invisible catalyst of our visible world. Now I want to know your thoughts in the comment section below. And don't forget to subscribe for more amazing videos. Thank you for watching.